Let's have a look at offsets from the long chord. So this is a lecture by Gathigira Steven. So let's see something under the offsets from the long chord. And the long chord, that is the longest distance achieved or traveled through the curve. So here offsets or ordinates from the long chord. So let A, B and BC be two tangents meeting at point B with the deflection angle of theta. So this is the deflection. The following data can be calculated for the setting out of the curve. So the tangent length is calculated. The formula of the tangent length is there, and the T1 and T2 are marked. Then the length of the curve is calculated with this formula. I know there we have a concept about that. Then the changes of T and T1 can be found. Then the length of the long chord can be calculated. So the length of the long chord, so this is the formula of finding the length of the long chord. So R 2R sine theta a half. So this is what we need to be calculating. So let's go ahead. So the long chord is divided into two equal halves, and the left and the right halves, so they are equal. So the curve is symmetrical in both the halves. So what will be done on the one half will be the same as the other. So the mid-ordinates, so that is represented here. So the mid-ordinate is calculated as follow. So the mid-ordinate O is equals to distance DE. So here we have it. So the mid-ordinate here, the distance, so the mid, that is D distance DE, that is the mid-ordinate, and then is calculated that formula. I'm sure you have it or you know it. So the verse sine of the curve is equals to R into 1 minus cos theta and a half. So that is a half of cos theta, and again R, or that is the radius, is equals to the distance OF, and OD is equals to, so let us see here. So the distance that is calculated and the distance that we are looking for here. So the distance, so here we have the offset O. Then let me just go directly. So this offset X is the distance from P to T found here, and then this here we have 0.1, so point, so this point origin 0.1, 0.2 found there. Then so by having this triangle here, our triangle this T to 0.2 to where our origin is here at 0, that is the triangle that we are looking for. And again, so our offsets, our original offsets, we have the formula, or we can calculate that. So I'll be using that to see what we can do better. So here OF is equals to R. We need to see that on the diagram in order for us to understand. So O to distance of F, I'm trying to, so it should be E. So O to E, that is equals to R. So R is the distance from here to E, and also R is the distance from here to T, and also the other. So that is the radius of the circle found there. So that is to be, so that is O to E, this is E. Then O to D, so that is the distance found here. So the distance of O to D, that will be our r, which was the distance O to E, minus the offset's origin, that is OE. So that's why the distance OD is equals to R minus the offsets of the origin. So you remember that. So that distance will be equal to that. And then we move ahead. So from the triangle that we have here, triangle OT1D, the triangle OT1D, so this is the big triangle found here, is equals to, we need to see, so this is the distance OT1. We can write that here. The red one. So O to T1 squared plus T1 to D. So distance T1 to D squared will be equal to so let me do that again rightly. So this is the hypotenuse, that is what we'll need. There we'll have our equal sign. So let me see to that again. So the distance, let me start here. So the distance OD squared, the distance from here to D, plus the distance T1 to D, that is distance T1 to D squared, will be equal to the distance T1 to O, or O to T1, either way. So I had proven that earlier by the 3, 4, 5. So if the 3 was here and here we have 4, by squaring both these two we'll get here 25. Under 25, that is 5 squared, and that is how that is proven there. So that is the triangle that we are in search of. Let us simplify that triangle. So the distance O to T, already we had it there. So that is R minus our offset origin squared, then plus T1 to D2. So T1 to D2, this is the distance from here to here, and that distance was represented by we can say that is L. So that can be L and a half, or in this case let me have it, yeah, that is L. So L, that was the distance from here, from T1 to T2. So a half of it, that will be a half L squared, then is equals to T1 O, this is the radius, so that will be R squared. So by doing that, this is our equation. By simplifying it, I need to find the offset origin. So I want to prove the answer of the offset of origin. So by removing this bracket, so here we'll have a square. Oh, yep. Or I can, yeah. Or let me leave the square there. Yeah, I'll use it later. So by separating this, they will have R squared minus offset origin squared plus 4 over 2. So that is L over 2 squared is equals to R squared. So by having, let me see which I can now. So I want to shift everything. So let me just take this offset origin to the other side directly. Yeah, that will be much simple, just like what they have done here. So this is the equation that I'm trying to prove to you. So those who are not clearing seeing my what I'm writing there, this is the equation that I'm trying to prove. So this is the equation that yeah, we had read there. So either way you can square it or you can have it remaining there. So the same by changing the, so here they did a square of that. That can be done. So here we have r minus the origin square is equal to the square root of r square minus l over 2 square. So offset origin is equal to r minus, so because we'll need to remove this negative, so here we'll divide by a negative, and here all our answer will divide them by a negative. So that's where the r, which had a positive earlier here, I will need to shift in order for us to have this finally right equation there. So our offset origin is equals to r minus the square root of r squared minus l over 2 squared. So that I had proven it here. So by changing that, these all values will go on the other sides. Then we'll remain with our offset are here, so that is right. So here again we can do that, then here will be r over offset 2 and then plus l over 2 is equals to r over 2. Then we'll move this on the other side, and also we'll move this on the other side, and we'll have our final formula as being the right one here. Then we go ahead. So thus the mid-ordinate can be calculated. So that was done. Then considering the left half of the long chord, the ordinates 1 and 2 are calculated at distance x1 and x2, which are taken from D onwards to the tangent point T1. Then the formula for calculation of the ordinates is decided as follows. So let P be points at the distance x from D. Then, so here we have our P's. Yeah. So P is the distance x from D, and then this is P1, P2, which is the same. So the distance P1 to P2 is the same as x, because that is an opposite, that is opposite equal perpendicular. And then it is required for the ordinate. So this is the ordinate of x, or offset of x. Then the line P1, P2 is drawn parallel to that. Then from there we have a triangle O, P1 and P2. This is again another triangle here, O to P1 to P2. This is a triangle, and the distance here is the same as that. So the distance from here P1 to P2, that is x. We'll do the same. So we'll square the length, and it will give us the square of the hypotenuse. So the distance O to, we had calculated that earlier, so we can do that again. So the distance that we have here, the P1 to P2, that is x. Then we need to find the value of O to P2, which we can see here. So there we have so this O P1 squared is equals to O P2 square plus P1 P2 square. That is the distance that we are calculating. Then we have, so the distance O to P2, that is R, seen here in our diagram. O, so this distance O to P1, O to P1 seen here in our diagram, O to P1, that is R, the distance R. So this is our hypotenuse is R. Then this P1 to P2, that is X, as you can see here on our equation. So that is X squared. Then O to P1. Earlier we had looked at that. So the distance OD, we had it as R minus offset origin. So from O to D, that is R minus offset origin. Then we need to find the distance from R to P2. P2 is just below the E, and the distance from D to P2 is the same as this distance of P to T. So, and that distance is offset X. That's where the reason. So here the distance of O to P2 will be that distance of O to D plus the distance of D to P2, which is equal to this distance of T to P there, that is offset X. So we'll have our answer as R minus offset origin, then plus offset X, that is the distance from here our origin to where P is. That is what has been done here. So we'll have that everything is in square. So we'll have to remove the brackets. We can start here. So this X squared will be brought to the other side. So this will be R squared minus X squared. We'll have gotten rid of that. So we'll remain with this. So by opening the brackets, so here we'll have the square root, and the same will be done here. So by doing that, our square root will cancel the square there. So we'll remain with R minus offset origin plus offset X is equals to the square root of R squared minus X squared. We'll we are in great need of the offset X, that is the thing that we are calculating. So we'll have to shift everything here on the right hand side. So we'll subtract, so everything here is in bracket, and that's how our final formula becomes offset X is equals to the square root of R squared minus X squared minus R minus offset origin. So that's how that is done. I hope you have gotten that concept of how they got these values here of the representation of that triangle there. So the ordinates for the right half are similar as those obtained from the left half. So this is the formula that is going to be used. So in setting a curve, you will need to know where these offsets are, and these are the offsets that will be used to set the curve. So offsets will be from here the long chord to a point on the curve, and that is the offset that will be needed to calculate. So I'm sure an example of that I've done it somewhere. So go through the videos and you will see the right answer. So the right thing done. So the R squared X squared is the distance, and then the offset of the ordinate. So this is the original. In calculation of the equations, this never changes. So you'll have already calculated it earlier. You can use this formula of calculating the offset origin, and this offset origin is the same as the mid-ordinate. So you can also use the formula of finding the mid-ordinate. So that formula is the same. So and this is the formula here. So you can use that formula to find the origin, offset origin, or you can use this formula again. After having done that, you'll need to calculate the offsets given on the figure. So there can be many offsets. That will depend on the long chord. So you'll divide half of the long chord, then the half of the long chord will give you the number of offsets you'll need to calculate, given that you'll have been shown the interval in between those offsets, and that will give you the answer. So remember to watch the next video, it will be informative, also on the simple circular